Hello, in this video we are going to take a look at the paper Spatial Commonsense Graph for Object Localization in Partial Scenes. The idea of this paper is depicted in figure 2. Let's go to that. In figure 2 here, first imagine that we have one room full of objects. For example, I have a TV here, a table here, a chair. We have the bookshelf, and also we have door. And now we have one other object, and our intention is to find the location of this bag. So we don't know where the bag is located in the room, but we know we have one bag. If we find the distance of the bag with respect to other objects, we should be able to localize that. For example, if I find what is the distance of the bag to TV, or what's the distance of the bag to table. So we call these things proximity. So if I find these proximities, I should be able to localize that. And as you know, for a 3D localization, if I know a distance of objects from 4 different reference points, I should be able to do that. Just like GPS, that we need, for example, 4 satellites to give us the exact location in 3D, similar to that. And if you want to have for 2D, for example, from the bird's eye view, so with 3 objects, that should be enough. But for now, we consider the distance to all of the objects in the room. So the idea of this paper is very interesting. They are trying to introduce something called common sense. So let's look at that. So that is depicted in this block. So the idea is to add a couple of nodes. So we are going to add, for example, the node living room, library, reading, relaxing, and exit. And we are going to have 2 different types of edges. The first type is called used for, and we see how these nodes are related to the objects in the room. For example, chair is used for relaxing, or TV is used for relaxing, or door is used for exit, and table is used for reading. The other type of edge that we have is called at location. And for this one, we are gonna say, for example, chair is at living room, or chair could be at library. Table could be at library, but for example, TV, we don't associate TV to the library. And we could say bookshelf is also related to library, and so on. So having this graph that we added these nodes, and now we have a graph that we have original nodes as objects, and now we have these concepts nodes and relationship to the objects. Now we are able to go forward and then try to predict those distances that originally we were looking for the bag to all of these objects. And after we've trained the network, we will find the distance of the bag to all of the other objects. For example, distance of the bag to the bookshelf, to TV, to table, to chair, or to door. After we have all of these distances from objects, we just able to find in a space where would be the best point that would optimize consider all of these distances. So that's just gonna be the intersections of all of these distances from each other, basically. So by doing this, we should be able to find the location of the bag objects that we know exist in the scenario, but we don't see that. Okay, let's look at one of the examples. So for example, if we go down in the paper, here, for example, here, this is a room, and in this room, imagine that you have a robot that can observe the room and see objects. And when you see the objects, those locations that you can observe are depicted in yellow. So for example, you can observe this section, or you can observe these sections. And when you observe these locations, you are identifying the objects in them. So for example, desk, for example, here you see in the red location, we see a desk, for example, here. Okay, now we see these yellow sections of the rooms, and we know the location of the objects that we saw in the yellow sections. and we have no idea about the other sections of the rooms. Those are just dark for us. But we know there is one sofa in this room, and our intention is to find the location of that sofa. So from our common sense, we could say the sofa should be in this corner of the room. Okay? And that is exactly what this algorithm is doing, and it's predicting that at this location, which is very close to the actual ground truth location. And that's the beauty of this, because imagine that you might be able to use this idea for other applications. So you know there is an object, but you don't see that. And from your common sense, from your knowledge, you are going to predict where that could be. So this idea might be also useful in outdoor applications, for example, for self-driving cars, especially for handling occlusions. For example, imagine a scenario like this, that we have a crosswalk here, and imagine that there is a pedestrian here and moving to the right. For the first few seconds, I see that person, and I know there is a human here. But when that person reaches this location, so that person is occluded by this truck. So because of the occlusion, I don't see that pedestrian. This is very similar to this problem. So you are trying to localize an object that you know that object exists, but you just don't know where is that object. And maybe that common sense graph or some sort of modified version could be helpful here. One of the other points that we could think about that here is that we as humans, when we look at the scenario, we are not just trying to identify objects. For example, we here ask machine learning to just localize and identify objects in scenario for us. But humans have higher level understanding. So for example, as a human, we have a understanding of the geometric constraints. For example, we know that two cars are not gonna pass through each other, or we know kind of average speed of the objects in the scenario. We don't expect, for example, a pedestrian to move as fast as a car, for example. And these high-level understanding that we use as humans for seeing around us, seeing the scenario, helps a lot in our perception. And maybe this idea of introducing concept nodes and trying to integrate that to our perception, that could be also useful in having a better perceptions. So instead of limiting our machine learning models to just identify the objects and localize them, maybe we can introduce more nodes, like here, concept nodes, maybe geometric concept nodes into our graph, that we could integrate them to our perception and try to improve our scene understanding. Okay, this was a quick summary of the idea of the paper Spatial Commonsense graph, and thank you so much again for watching this video.